Hello and welcome to Beamer, folks. This is my debut video upload, so please be a little patient with me. Over recent years, I've enjoyed making a number of electronic projects, and I'd like to share some of these with you. By now, you've probably gathered that the focal point of my curiosity is a barometer. This elegant chap on the left-hand side, probably a value in excess of £4,000 or £5,000, is beyond my means. You can get for a couple of £100 a smaller barometer, an imperial barometer, but more than likely it's well and truly beaten up. My device doesn't look anywhere as elegant as this, but it's proved successful and quite precise. It's a 30 inches of Mercury barometer, imperial barometer, and it's constructed primarily out of a BMP 280 barometric sensor. I've provided three basic features to this barometer project. One is I've used an analog meter. I kind of preferred it to any other form of sophisticated LED or LCD metering, simply because it's relatively simple and it is consistent with the sort of theme of an imperial old barometer. The second feature is a null facility, and what I did there is that the rising and falling measurements around sea level, normal average sea level, are very small indeed. It's very small deviations. So what I did was at half FSD, I centered the meter and then amplified these rising and fall changes onto the center meter position, effectively creating a null facility. This has worked out very well, and it is the way in which I always view this project. There are other features, but I do like this null facility. It gives you great indication of weather change, barometric change, and is quite effective. Additionally, there is a 3 LED that is green, white, and blue, representing a barometric gauge. The green is for a falling barometric number. The white is for the same as before barometric number, and the blue is a rising barometric number. The heart, the brains of this little project is, as you probably guessed, an Arduino. And the Arduino I used was a Pro Mini Atmega 168 5-volt module, and that seems to be very effective. The build as a whole, I would probably describe as challenging. It's probably not for the novice, but you know, if you can handle it, then go ahead with it. The results are very rewarding. Finally, the unit is housed in an upcycled, I said it wasn't elegant, an upcycled takeaway box. I chose particularly clean, unstained, unsmelling upcycled box and takeaway box, and that's worked effectively. One is that it's no cost. Two, that if you manage to muck up the drilling or whatever, cutting of the box, you know, there's another one available. I've got a collection of these. And secondly, the box is actually surprisingly strong, although I probably wouldn't stand on it, but then you wouldn't really be standing on a barometer anyway. It's a precision instrument. Okay, this is, I thought it was about time to introduce you to the unit itself. As you can see, it is constructed with an upcycled takeaway box. It's a slightly deeper takeaway box than I would have preferred, but it has to accommodate the analog meter. So that is the first feature that I will show. This is analog meter. It is a 5 milliamp full scale deflection, and I operate around the 2.5 milliamps half FSD position. If you can, I don't know whether you can see the needle here, but it is just below 2.5. Let me put this into that position, which is a direct reading of the barometric pressure. The barometric pressure today is just about spot on the normal average sea level barometric pressure, and I don't know whether you can see that, but it's slightly under 3, and 3 represents 30 inches of mercury. I've kind of named this unit MAB, meaning Mercury Arduino Barometer. Moving further north, we've got the LED gauge display of 3 LEDs. At the moment you've got green, but it does green, white and blue. Green represents a falling barometric pressure. The white indicates, in fact it comes on as white and a colour, so that will indicate that if white is showing, that it indicates that the pressure is the same as the last reading. Right, now what I do now is turn the unit through 90 degrees and show you the switches. Hopefully that's visible. Yeah, looks like it. First switch on the left hand side. There are 4 switches and a power indicator. First switch on the left hand side is a beeper on and off. If you have a beeper on all the time, it could be irritating. There's an option to turn it off. It's very simple. The next switch in line is an option whether you want a sample period of time of 10 minutes or 10 seconds. This is the LED gauge sample time. It's very different to the analog output. The analog output is completely on a separate control system to the LED gauge. But this switch here tells the LED gauge to sample for 10 seconds or 10 minutes. At the moment it's in the off position, so that's 10 minutes. If I switch it on, it becomes sample updating every 10 seconds. The power indicator, as you can see, is ramping its brilliance up and down. That kind of shows me that the Pro Mini is functioning and doing more or less what it should do. And that's the reason why it's there. You will see a high bright come up when the sample is being taken and transferred to the LED gauge, and that is to indicate without sound, looking at there, that actually a sample has been taken. The next switch position is for calibration purposes, and that is a calibration of 2.5 milliamps that gets set when you initially make this unit and set it up, and gives you the opportunity to check it periodically. So it's normally in the off position. The last switch in the line is perhaps a little bit more complicated, and I'll rotate it back again through to here, putting that there. Okay, hopefully that is, yeah, that's in view. Okay, this last switch switches between ordinary barometric pressure readings, very similar to a barometer, and a null feature. You can see with the ordinary barometric reading, it is reading as it was before, just under 3, meaning 30 inches imperial measurement. Now if I switch this switch to the on position, it immediately drops to just under 2.5 milliamps. That's indicating that there is a very slight deviation to the negative of normal average sea level barometric pressure. So that is my reference of 2.5 milliamps, is spot on average barometric normal pressure. And as you can see, it's very slightly under, which is indicating that it is a falling barometric pressure. The speed of change of this is actually quite slow, but you can get fronts moving across us within 12 hours, 24 hours, and you can see this meter moving, say, between 2.5 and 3 within 12 hours. So everything barometrically moves quite slowly. In saying that, as you can hear and see, if you have the sample period set to 10 seconds, there appears to be quite a bit of change going on here. At the moment it's falling, and the next time it's rising. What's going on there is, if you've got a short sampling period, you can be measuring very rapid transient changes in barometric pressure. The sensor in here, which is a BMP280, is very sensitive to minor changes barometrically. So these changes, if you have it set in 10 seconds, whilst interesting, can be not showing the longer trend barometric shift. That you really need to switch into the 10-minute option, and then you know that when it's sampled 10 minutes later, that you will get a genuine shift in barometric pressure, or indeed not. It might actually still be the same barometric number, but more than likely it would be either higher or lower. The next thing I was going to mention, I think that's more or less it. The next bit I'm going to show is the numbers associated with this barometric precision device. Just before I go, I'll switch to the calibration reference, switch that on, and you can see just a minor shift, but it is set absolutely spot on 2.5 milliamps. And if this device is not calibrated, there's a little pot inside there that you can adjust. It does need to be calibrated exactly to 2.5 milliamps. That's more or less it. The next bit, I will go through the numbers associated with this device, and there we are. Okay, I just thought I'd like to add 2 points to my previous introduction. The first one is that the null feature is the deviation has a gain associated to it. So small variations in deviation are magnified by this gain feature. The gain within the unit is times 20. So small changes will see large changes on the null. Secondly, the LED barometric gauge, when switched to 10 seconds, the acute variations one experiences is partly due to the sensitivity of the BMP280 to very minor atmospheric pressure changes within the room. So that could be window, draft, doors opening, people moving around. So that's one of the reasons why a 10-second option can be relatively not accurate reflection upon the true trends in barometric pressure.
This is Beamer signing out for now.